Hello, my name is Ian Barnes. This is my lab for Oscillations. So the purpose of this lab was to evaluate a video using tracker to observe the change in energy of an oscillating spring with a mass attached. Then we will compare that predicted motion with the observed motion using the coded model in GlowScript, and we will plot the energy changes computed in the model with kinetic, gravitational, and spring potential energy, and then lastly total energy. And then we will see if the energy principle is upheld. So the lab setup was the system was the spring, mass, and the earth, and there were no surroundings. And in the video, the mass is attached to the spring, and it is released in a way that it oscillates up and down as well as left and right. And we know that the energy in the system is conserved due to the principle of conservation of energy. We're looking to see if the model falls with kinetic, spring, and gravitational potential energies acting accordingly with that conservation of energy. And then we also need to make a GlowScript coded model to represent the system and compare the two to see if the energy is conserved. So the principles I used for this lab were Newton's second law with change in momentum is equal to change in time, and then position and velocity update with those we've used in the past, and then the gravitational potential energy, which is just equal to mgh, and spring potential energy, which is equal to 1/2 ks squared, and then kinetic, which is 1/2 mv squared, and then the energy principle, which is change in energy equals to q plus w, where w is the work from surroundings and q is the change in heat. And so there's no surroundings and there's no change in temperature, so change in energy is equal to 0, so we know that energy final is equal to energy initial. So tracking the video, I found the object mass was 0.402 kilograms, and the length of the spring was 0.7 meters based off the pre-lecture video. And I tracked the initial position and velocity to be negative 0.0868 in the x component and negative 0.7204 in the y component. And then initial velocity I calculated to be 0.0409 in the x direction and negative 0.0273 in the y direction. And then with the GlowScript model, as you can see, I was mostly just implementing initial values and then equations to calculate the energies. So in the far left image, I put the ball mass, and then I put the initial velocity, initial position vectors, and then I put in g, and then the spring constant and the relaxed length of the spring just based off the pre-lecture videos. And then I started using the equations with the ball position and the spring position to calculate L, and then L hat calculating by L over magnitude of L, and then S was just the magnitude of L minus L naught. And then I put in the equation to find kinetic energy, potential gravitational energy, and potential spring energy, and then the total energy, where you just add all those energies up. And then I initialized the original kinetic energy and potential gravitational and spring energy and total energy just to make it like the starting loop. And then in the loop, I calculated the gravitational force and the spring force, calculated the net force, and then I also did the ball velocity update formula and ball position update formula, as you can see there. And then I calculated the length of the spring again just to update it throughout the loop. And then I did the same thing with kinetic energy, potential gravitational energy, potential spring energy, and total energy to calculate the loop again. And I also did the time. And then the GlowScript results were the change in energy graph. And as you can see, the total energy is 0 throughout. So the principal energy of conversation is 0 throughout, and the x position and y position, they're not totally accurate with the GlowScript model, but it was mostly due to two sources of error, which that it's not actually isolated from surroundings, causing there to be work done on the system, which would make the change in energy not 0, and also human error with me putting the center of mass on tracker. It's not very accurate to where the actual center of mass is. And for the discussion questions, is the energy principle satisfied? I will say yes, because it's 0. The total energy is 0 throughout the period of oscillation, which shows that there's no external forces acting on the system, so the change in energy must be 0. And then my estimation of oscillations were, in the x direction I calculated to be 0.724 newtons per meter, and in the y direction to be 0.85 newtons per meter, and the two kVos are reasonably close, but the y direction is generally more reliable since the ball oscillates with a larger amplitude in that direction, giving cleaner zero crossings. And thank you.